The topic of this video is graphing piecewise-defined functions. Alright, here's our problem. J of x equals the cube root of x if negative 8 is less than or equal to x is less than or equal to negative 1, x cubed if negative 1 is less than x is less than 1, and cube root of x again if 1 is less than or equal to x is less than or equal to 8. Okay, let's go through the steps. The first thing you want to do is look for any equalities after the word if. Remember, an equality would be x equals number. Well, we don't have any of those. So that's kind of bad news for us because that means we don't have any of the easy pieces. We have all hard pieces to do for this particular problem, which means we need to create the entire graph of all three of these pieces. Now, the one thing that is a bit of a saving grace is that two of the pieces are the same. They're both the cube root of x. So really, we only have to make two graphs. One of them, we just have to cut 4 times instead of 2. All right, so let's go ahead and begin with our top piece and create the graph of the cube root of x. This is one of the functions from the library, and therefore you should be able to create this graph just as quickly as I'm about to right now. You should have all of these points perfectly memorized. You should be able to create your graph scale. You should be able to plot your points. So negative 8, negative 2. Let's move this negative 8. This is in the way. Okay, let's say this is negative 8, and this is negative 5. This is 5 and 8. All right, great. So here we go. Negative 8, negative 2 is here. Negative 1, 1, 0, 0, 1, 1, and 8, 2. Okay, problems like this are the reason why it is so important to know the functions in the library of functions. You need to be able to create your graphs quickly and easily so that problems like this don't take 30 minutes. Okay, there we go. I've created the graph of my cube root function. All right, now I have to cut it. And where am I going to cut it? Well, after the word if, I see the numbers negative 8 and negative 1. And because this is a very special problem where I have the same function showing up more than once, I'm also going to cut at 1 and 8. So negative 8, negative 1, 1, and 8 are the 4 places that I'm going to cut this graph. So right through this dot, I'll make a vertical cut. Right through this dot, I'll make a vertical cut. Right through this dot, I'll make a vertical cut. And right through this dot, I'll make a vertical cut. All right, what part of the graph do I keep? Well, these are between type inequalities, where x is between negative 8 and negative 1, where x is between positive 1 and positive 8. So that's the parts of the graph that I'm going to keep. The part that's in between these two cut lines, so this goes away, and in between these two cut lines, so this goes away. And I also have to get rid of the little snippet in the middle here, because I only want the parts that are in between my pairs of cut lines. Okay, now I have to put open or closed dots where the curve meets the cut. This is a closed dot, this is a closed dot, this is a closed dot, this is a closed dot. So I need a closed dot here, 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 and here. And let's label those locations. So this is negative 8, negative 2. This one is negative 1, negative 1. This is 1, 1. And this is 8, 2. Okay? These may look like straight lines. I assure you they are not. They are curved. It's a very gentle curve, but you would not draw this or this with a straight edge because they are not straight lines. Okay, we've done the top and bottom pieces. Now we're ready to do the middle. The middle says j of x equals x cubed. That's the cube function. And you should be able to create the cube function just as quickly as I can. Those are the 5 points on the cube function. I'm going to create a square centered at the origin to establish the scale. I'm going to get rid of the corners here. That tells me the location of 1 and negative 1. So there's 1 and 2, 1 and negative 2, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8. So down here is negative 8, up here is positive 8. Here's negative 2, sorry, that's positive. Here's negative 2. And let's plot our points. All right, so negative 2, negative 8 is here. Negative 1 is here. 0, 0, 1, 1, 2, 8. All right, and we're going to create the graph here. This is the cube function. All right, now there's one small piece of the cube function that I want you to pay very careful attention to. If you zoom in very, very closely right here, when you look at the like a computer-produced graph of this function, it is perfectly flat as you go through the origin. Flat as you go through the origin. So that means that for just the tiniest bit of time, this is a flat line as it goes through the origin. Make sure you are drawing it that way, because that will be important to get the proper final picture. Okay, great. So we've created our entire graph. Now we're going to cut it. We cut it at -1 and +1. So that would be here and here on our axis. So vertically through that point is where we're going to cut our graph. And because this x is in between -1 and 1, then we're only going to keep the part of the graph that is in between the cut lines. So that goes away, and all of that goes away. And the only part of our graph that we're going to keep is this very tiny piece right here. This is the only part that we're going to keep. And you want to make sure you've drawn that shape correctly. Remember, it has to be perfectly flat through the origin. Okay, what kind of dots do we use? Well, in this case, it's the opposite of what we had before. We've got open and open. So where the blue curve meets the red cut, we need open dots, and that would be here and here. The location would be 1, 1, and -1, -1. All right, so now that we have all three of our pieces, right, this is the top line of the piecewise-defined function, this is the middle line of the piecewise-defined function, and this is the bottom line of the piecewise-defined function. Now we just have to put it all together to make our final picture. So we're going to draw a square centered at the origin. Then we're going to erase the corners. This will establish our scale. So the distance from here to here is 1, so from here to here would be 2, and then 3, 4, 5, 6, 7, 8. Over here, -1, -2, -3, -4, -5, -6, -7, -8. Going up, we have 1, 2, 3, 4, 5. And going down, -2, -3, -4, -5. And now we just have to put all the little blue pieces together. Let's start with this one over here, the one with the open dots. So we have an open dot at -1, -1. We have an open dot at 1, 1. And the shape that goes through them looks like this. Flat through the origin. Okay, that's that little piece. Now let's do this one right here. We have a closed dot at -8, -2, so that'd be here. And we have a closed dot at -1, -1, which is the same as the position of this open dot. When an open dot and a closed dot are in the same place, the closed dot fills the open dot, and so we get this as our part of the graph. And now finally, this little piece, we have a closed dot at 1, 1, which fills this open dot, and a closed dot at 8, 2, and then these are connected to form this shape. And so, this is our final picture. We have now created the graph of this piecewise-defined function. And in our next video, we'll talk about whether it's continuous or not, and we'll also determine its domain and its range.